All right, so in this section, we're focusing on Git tags, which we have not really talked about at all, but they're pretty straightforward, nothing super difficult. And they're also not used all the time. It depends on the project, it depends on the company or the organization that you're working with, or just your personal habits. Most often these days, tags are used to mark different releases, different versions of a project over time, like, version 7.1.0, version 7.1.1, and so on. So important to understand, I'll say understanding Git tags is important. Understanding semantic versioning is not really tied to Git. This is a concept on its own. I'm teetering between important and nice to have because it's kind of these days like the de facto use case for tags. But anyway, I'm getting ahead of myself. I'll say that viewing tags is important. Creating tags, lightweight and annotated tags is important. And being able to push tags is important. Moving tags, diffing tags, deleting tags, nice to have. I mean, it's all kind of in this gray area between important and nice to have, but nothing, in my opinion, that is critical here. If you end up working with tags a lot, you'll get very good with them, and it's very straightforward. Honestly, they're pretty simple. So I think it's worth checking out the section. For as many videos as there are, it's actually pretty short. Some of them are like 1 minute or 1.5 minutes. So don't let it intimidate you that there's 11 videos or something. Anyway, let's get started. We're going to talk about tags. Here we go. So next up, we get to talk about Git tags, which are very useful, but also, fortunately for us, are pretty simple to pick up. They're not a very complicated concept. The main idea behind Git tags is that we can tag particular commits. We can label commits by creating a Git tag, a reference to a moment in time. So these tags can be anything. We can name them whatever we want, but typically tags are used these days to mark version releases for projects. So again, think of tags as like a label pointing to a particular moment in time, kind of like branch references, except that a branch reference, like these here, right, these change. If we add a new commit to the master branch, this reference moves. It points to the tip of the master branch, the next commit. But a tag will actually stay referring to the same commit that we set it up on. So on the Git docs, they explain this. Git has the ability to tag specific points in a repository's history as being important. Think of it as like a sticky note on a commit. Typically, people use this functionality to mark release points, but again, you don't have to. But that's the context I'm going to demonstrate it in. It's what you'll see the most, really the only thing I ever see tags used for. So tags allow us to do things like this. Everybody who ever sees this repository, I'm tagging this one commit as our version 3.1.0 release for whatever this software is that we're making. So that is always going to be there. No matter how much more work we do, thousands of more commits in the master branch, lots of merges, this will always be 3.1.0. It's tagged that way. Yes, we could move the tag, but we have to do it manually, unlike with a branch reference, which automatically updates. So I can tag different points as different releases in our history, and all I'm doing is marking them as important moments. And a lot of the time this happens, right? You would have a new version, a new release, when some code is merged into the master branch. If we're working on a big project, a big open source project, lots and lots of contributors, at some point, some code is merged in, and whether it's a bug fix or a whole new refactoring or some radical change, that typically marks a new release. So that's why I'm marking or I'm tagging these merge commits, but that's not always how it works. All that I want you to understand for now is that a tag is just a pointer to a commit, a moment in time. It doesn't have to be in the master branch. You can tag any commits. And when you tag that commit, that tag stays there. It refers to that moment in time. And these names can be anything. Most of the time, we're talking about versioning, but you could name them hot dog, pickle, and bloober tuber if you wanted to. We have complete control over what we tag things as. So there are two different types of tags that we're going to discuss. There are lightweight tags. Lightweight tags are simpler, they're lightweight. They're just like a name and a label, that's it. Think of what you see here, a name referring to a moment in time. Annotated tags include additional information, including a tag message, kind of like a commit message, the author's name and email, the date. And for that reason, because they include all this additional metadata, they are generally preferred in a lot of big projects, they'll ask you to use annotated tags, not lightweight tags. So I'll show you how to do both of them. They're very simple. It's really just one command we need to cover, which is git tag. And then we'll go on from there. But before we go any further, I actually want to talk a little bit about versioning, because tagging and versioning are kind of tied together. That's the main use case for git tags. I want to talk about semantic versioning, and that's what we're going to cover in the next video. So as we talked about in the previous video, the most common, really the only use case these days, well, I shouldn't say only, by far the most common use case though, for tagging is in versioning, in marking release points for some piece of software. The Git docs mention this, right? Typically people use this functionality to mark release points. It is really the thing tags are used for. So in this video, we're not going to talk about tags specifically. We're not going to see any commands, but I want to talk about semantic versioning. Semantic versioning is a protocol, a specification, a set of rules and requirements that dictate how version numbers are assigned and incremented, basically the meaning of these three numbers with two dots between them. You've probably seen this system before. It's really widespread these days, and it is tied tightly to the usage of git tags. Okay? So the whole point here of semantic versioning, it's an actual specification that we can take a look at. It's a nice and short document. Not bad compared to some of the other software specs out there. And the idea is just to lay out this set of rules for making versioning transparent and consistent and meaningful, so that these release numbers actually have meaning encoded in those 3 digits. So the system is 3 numbers with 2 dots between them, and each spot indicates something different. So on the far left, we have major releases. Then we have minor releases in the middle, and then patches on the right. So typically, if you start off development with some application or some library that you're creating, the initial public-facing release will be 1.0.0. And I believe it's actually codified in here somewhere. Let's see. Version 1.0.0 defines public API. Yes. So that's one of the rules here. There's a couple of rules. Then, once you have that initial release out, small changes, patch releases, are going to be indicated here on the far right. So patches do not contain new features or significant changes, definitely no breaking changes, often just bug fixes and minor changes that don't impact how people use the code or the piece of software. So if people are already using 1.0.0 and they're comfortable with it, if you release 1.0.1, that's a patch, and you shouldn't change anything that those people are using. You shouldn't, surprise people or break anything that they're doing. So patches are small and they happen pretty frequently. So that's what this number indicates here, right? And you increment that by 1 for every patch. So there could be another patch, and it would be 1.0.2. Then we have minor releases. So minor releases signify new features, new functionality that's been added, but everything is still backwards compatible, no breaking changes. So typically, new functionality, new features will be optional in a minor release. It's just like, hey, here's some new stuff, but you don't have to completely reconfigure everything you've done as a user. You don't have to rewrite code, but you could add this in. So that's what minor releases are for. And whenever there's a minor release, you're supposed to reset the patch number back to 0. So then you could have 1.1.1, 1.1.2, 1.1.3, but then as soon as there's a new minor release, 1.2.0. And then we get to major releases. Major releases are for significant changes that are not backwards compatible. Features may be entirely removed, changed substantially, right? It will often include breaking changes. So there's a big difference between a minor release and a major release. And the protocol is that for a major release, you increment that number, and then you set the other 2 back to 0. So that's the basic concept. It's pretty simple, right? The system here is just 3 numbers, but it makes it clear to any user or consumer of some piece of software how significant a change is in a new version, which is always very important, especially if you're relying on a piece of software, a library, as a dependency for your own software that you're building. So we can take a look at some examples. For example, Bootstrap. Bootstrap, if you're not familiar, I've mentioned it a couple times in this course just as demos. Very popular CSS framework, component library, whatever you want to call it. And on GitHub, we can actually go and click on tags, which again, we haven't seen how to make tags yet. But then we can click on releases right here. And we can see a whole bunch of releases. So currently we're on 5.0.0. By the way, V technically is not part of the semantic versioning spec, but most of the time you'll see a V before those three numbers. And also afterwards, you can append things like beta. I believe I talk about it somewhere on here. Yeah, a pre-release version may be denoted by appending a hyphen and then some other stuff afterwards. Anyway, if we keep scrolling down, we can see these different releases. Here are two examples. We have 4.5.1, and then the next release is a patch, 4.5.2. All right, so this number increments, and there's really not a lot happening here. It looks like it's removing one line of styles and then restoring some mix-in. So two minor things, no breaking changes, and we can see, the rules were followed, I guess, in this versioning, in this release number. Increment that far right digit. And then here's another example for React. This is their changelog on the React homepage. And if we take a look at something like 16.12 going to 16.13, this is a minor release, but there are some changes, right? Some new features, it looks like, generally more functionality compared to a patch. We can find a patch somewhere, like right here. This is a patch release, as is this, right? Tiny little changes, refactoring, bug fixes. Then here, we've got a minor. This is, let's see, what came before. Looks like this is a patch right there, 16.8.6, and then a minor release, 16.9.0. Right, we've reset that patch number to 0. And then somewhere we've got 17.0.0. That is a major release. You can see they kind of make a big deal out of it. They write a blog post on how to even update to it, what the main changes are, and there's a lot more stuff here. So that's the main concept behind semantic versioning. The version numbers, those 3 digits, or in this case, it's 4 digits, but those 3 slots separated by periods tell you a lot. They indicate the severity or the scope of a given release and its changes. Okay, so let's get back to tagging in the next video. Okay, so back to tagging. The first thing that we're going to take a look at is how we view tags. How do we look at existing tags? And we're actually going to use a repository that we clone that has hundreds of tags for us to play around with and inspect. We're going to use the React repository if you want to follow along. So I'll include the link along with this video in a resource, but it's just github.com/facebook/react. We can see currently there's, 137 tags, quite a few. This is where you view them on GitHub. But I'm just going to clone this down to my machine. So make sure I'm not in a Git repository, and then git clone. There we are. It's going to take a little while. It's a pretty large project. You can see it's going pretty slowly, but it will be, well, I won't say it's worth it, but it's a good tool for us to play around with tags. And while that's going, I just want to remind you the concept of a tag is to be able to mark or to highlight some point in history and have that be a static reference that does not update unless we explicitly want to move it. This example, v3.1.0, some release refers to that right there, right? This one commit, this is a minor release, most likely, and it's referring to that one commit. And at any point, I can go back and look at that, right? Everyone can see this is the moment in time where version 3.1.0 was released, right? This is that release. All right, so hopefully that repository is done cloning. The command that we're going to start with, really the command that forms the base of everything we do with tags, is git tag. But git tag on its own with no options, no additional values or arguments, will list all the tags in the current repository. So we clone this React repo. Okay, it did finish. If I cd into it, all right, we're in a Git repository. We're on the master branch. If I type git tag, I'm going to see a lot of different tags. These each mark a different release. So there's a lot of them. I have to scroll, and then to get out of here, hopefully you're used to this by now, type Q. Same as, when we're in git log, for example. Hit Q, and we get out. So these are all different tag names. You'll see that a lot of them start with V. That's pretty standard and conventional, although actually some of them don't. Some of them are missing the V. I'm not sure why that is. Just, I don't know. Some people didn't get the memo. But all these tags down here are all different versions, right? They follow semantic versioning. So we've got, the most recent 17.0.0. That's the most recent major release. And then here's a patch soon after, 17.0.1. And I'm sure you'll see some new tags, even if you're doing this a couple weeks after I publish the course, there will be new releases. So the exact numbers don't really matter, but you should have all these anyway, plus possibly more. So this is just listing a bunch of pointers. So each pointer, each tag has a name, right? And they're just version numbers, but those could be other names. They could be chicken or honey boo boo or something, typically version numbers. And they each refer to a particular point in time, a specific commit. But we don't see that right now. We'll learn how to inspect the changes or take a look at those particular moments in time. But for now, we're just listing the tags. And on the topic of listing tags, another thing we can do is filter them or search when we've got a bunch of tags like we do on this React project. We can use the -L. So it is an L. It kind of looks like a 1 there, but it's -L for list, which actually it's confusing. It doesn't have anything to do with this really. -L is telling it to list all the tags, which we don't have to do here, right? We just get them all. But if I add the -L, it's implicit when I do get tag. We're actually doing -L, we're saying list all the tags. But when we try and filter with some sort of wild card like we have here, this is a pattern that we're trying to match. So that star inside the quotes and asterisk here means any character. This is going to find all tags that contain beta in them. And we have to use -L in order to list them out. It's kind of weird, but that's just how it works. So as an example, if I wanted to look at all the, how about all the tags that start with 17? I think there's only 2. I can do get tag -L and then 17. And if I just do that, I'm looking for an exact tag named 17. It doesn't exist. But if I do 17 star, that means 1 or more characters, or actually I think it's 0 or more characters. But basically something after 17. Still nothing. Oh, well, that's my fault. They actually start with V17, don't they? Yeah, well, that was underwhelming. So there was no tag that started exactly with 17 and then stuff afterwards. They only had V17 and then content afterwards. So let's take a look again at all the tags. If I wanted to find all of them that contained beta anywhere, I could do this, get tag -L, and then some characters optionally beta, and then some characters optionally afterwards. And here we are. This one, right, 16.0.0 beta.1. This one ends in beta. This one has a dot after it. This one has a number. So we're getting all of those. And yeah, that's kind of all I want to show you in this video. So we can search through tags or filter for particular tags. Remember, you do need the -L here. Otherwise, it thinks that we're actually trying to make a new tag name. Because in the next video, or very soon, I'll show you how to make a new tag where we use get tag, just kind of like get branch, right? You can view branches with get branch and make a new branch with get branch. So anyway, -L just says list all the tags, and here's what I want you to filter them by. Okay, so that's our first example of viewing those tags, or at least the name of those tags. Next up, I want to talk about actually checking out those tags and going back in time and maybe diffing tags as well. So just like with branches, we can actually check out particular tags. The main difference, though, is that when we're checking out a tag is referring to a particular commit, not a branch, right? There's a big difference there, where a branch reference is always going to be updated to refer to the tip of that branch. We check out that branch, we're not in detached head. But if we instead check out a particular tag, we are going to go into detached head because we're basically just checking out a commit. Just like if we actually check out a particular commit, like, get checkout 532FB, whatever that commit hash is, that is going to put us in detached head. Same thing when we check out a tag, because a tag is just pointing to a commit. So it's not a problem, right? If we want to go back and actually work on an older version, usually you don't just make changes to an old release. The point is that a release is set in stone. When it's released, it doesn't change. That's what new releases are for, if you need to make changes. But let's say we wanted to go back and work off of some earlier release. How about, sure, 15.3.1, all right? All that we have to do is git checkout, that right there, 15.3.1. So that's a tag name, right? If I try and use checkout, normally we check out a branch or we check out a commit hash. That's not exactly what one looks like. Or we can check out a tag. And we see our favorite message that we're now in detached head state. You can look around, make experimental changes, commit them, and we can make a branch if we want to keep working. So I could do that, right? I could do a git switch -c, I don't know what I want to call this, branch from tag. I don't know why I'm using underscores here. Normally I wouldn't do that. But anyway, I now made this branch based upon that particular commit, which was 15.3.1. That's what the tag referred to. And we probably won't be able to tell much difference here at all. But that brings me to the next point, which is that we can actually diff different tags. So I think a more obvious diff to do would be between two patches. So what about this? 17.0.0, so that was a major release, and then there was a patch. So I want to see what changed between these two. I can do that very easily. So I can do git diff, and then v17 if I can type it, 0.0.0, and then I want v17.0.1, like that. And it looks like it was a very minor change. This is the only thing that changed. One file and just a little bit of, a couple of lines added and one line removed. So that was it. But if we were to compare something much more drastic, how about the last minor release on 16, so 16.14. So let's just find that. 16.14, it probably starts with a V. Is it on here? Yes, okay. 16.14.0, and compare that to 17. So git diff 16.14.0, and we'll compare that to v17.0.0. So this was the last minor on 16 and the first major, or a new major release, v17. And I'm going to be scrolling for a while. There are lots of files, lots of changes, lots of stuff deleted. I don't even know how much. It doesn't give me an indication of how much more I have to go, but lots of changes. It doesn't help that I'm very zoomed in to make the text large. But anyway, those are 2 points in time. They are marked with tags. We can check them out and make a new branch if we want to work based upon one of those points in time, or we can compare them. These are just moments in time. They're releases in this case, but as we'll soon see, we can create tags with any name. We'll stick with releases, but they're just a pointer. It's just like a sticky note on a commit that says, here is 17.0.0. So everyone in the future knows that this is where that release was. This is what we released right here. So that's how we can check out tags and how we can diff them. The next thing, of course, is making tags. Next up, we'll talk about creating tags. Now remember, there are 2 different types of tags. We'll talk about both of them. They're both very easy to make. There's lightweight tags, which are just a piece of text referring to a commit. And then there are annotated tags that have additional metadata aside from just a name, like a lightweight tag. They also include author's name and email, the date, and a detailed tagging message. All right, so here's how we make a lightweight tag, git tag, and then some tag name, some tag we want to create. And by default, it will point to whatever the head is pointing at that moment in time, or whatever the head is referencing at that moment in time. So basically the most recent commit on whatever branch you're on, right? If we run git tag, the tag refers to that particular commit. So if we're using React as the example here, if I git switch, I'll go back to master. And what do we have? The most recent one, I think, is 17.0.1. If I wanted to make my own new version, 17.0.2, I'll just patch something. What could we do? I don't know, we'll add a note to some file or something. This is going to be silly. Here's the contents of the entire repository. I don't know, let's go into the README and just change something very quickly. React is an awesome JavaScript library for building user interfaces. That's all we're going to do. And I'm going to add and commit that. So I'm on the master branch, git add README, git commit -m, I don't know, fix typo. It's not really a typo, but fix typo in README. Okay, so now if I want to tag this as a new release, which I normally would not do, certainly not for that, but if I wanted to, I can use git tag. And if I just do git tag with a tag name, like we'll do 17.0.2, it's a patch. The most recent one was 17.0.1, so this is just logically the next patch. Anyway, if that's what I want to do, I'll create a lightweight tag right here using the head, whatever head is referencing. Head references the master branch. The master branch, the tip is pointing at the commit I just made. Here we go. Well, doesn't seem like much happened, but if I do a git tag, it should show up down there. There it is. And I could keep moving, right? I could do some more work. Let's make another quick change. Let's say that we do another typo fix. I don't know. How about I like my pet chickens? All right, so we'll pretend we've done some code. It's just another patch. So we'll do git status. I'll make a new commit. I'll do full screen. How about update README? And, oh, geez, I forgot to do a -a if I want to add that change. Okay, so I can create a new tag again using the current head. So I'll do git log, one line, just to remind you of that. Head, currently on master, this commit, update README. So you can actually see my tag show up right there, right? That's the tag that I made earlier, 17.0.2. So now I'm going to do a git tag v 17.0.3. There we are. Okay, so I now have two tags that I've created in this video. There they are. They both refer to different commits. You normally, wouldn't work on the master branch like I am anyway, but just to keep it simple and short, that's what I'm doing. And why don't we take a look at the diff between 17.0.2, the previous tag we made, and then the most recent one we made. And there we are. That's what changed between those releases. So that's how we can make basic tags, lightweight tags, which are actually kind of frowned upon, or they're not as popular as the alternative we'll discuss in the next video, the annotated tag, which includes a bit more information. Okay, so to make an annotated tag, we use the -a option for annotated. Otherwise, it's still git tag and then some tag that we're creating. And just like before, it will be based upon the current head commit. Let's do some more significant changes now. Well, let's go make a new file, and we'll just call this new feature.js. And then I'll put some stuff in here that says, this is a new feature, not breaking change. And then we'll put some gibberish in here. We'll pretend that this is, some nice new feature, but you don't have to use it. It's just gonna be part of a minor release. Okay, so now I'm gonna add and commit. So git add new feature, git commit, add new feature. Great, and now I wanna create my tag. So git tag, and then I'll do an annotated tag. So -a, and then after that, the name of the tag that I want to create. I think we're on 17 point. If we're doing a minor release, it will be 1.0, right? We were on 0.3, I believe, 17.0.3. This is now a minor release, not a patch. So there we are. And you'll see that it's going to prompt me in my editor, just like when I do a commit. So it wants me to include a message, additional details if I want to. I can put stuff in here like this is more stuff about my tag. It's an annotated tag. Sure. All right. And then I close out of here. And that finishes the process. I now have that new tag, and we see it down here. That is my new minor release. So that's how we make an annotated tag. Just like with git commit, you can actually use the -m option to do it inline to pass a message directly. You can forgo the opening of the text editor, just like git commit. You still have to pass that in though. So if you use -m, pass in a message between quotes. So how do we view more information about one of those tags, right? We just made this annotated tag. How do I see who made it? How do I see that metadata, the tag message? Well, we use a command called git show, and then the name of the tag. So 17.1.0, this is going to show us the tagger. There I am, Colt, the date. Here's my tag information, right? This was the message I wrote, and then the commit that it refers to. So you can see that right there. So we can also do this for real tags that others have created. Like let's look at 17.0.0, that major release. So we can do git show 17.0.0. So here's the commit that the tag refers to. We can see, bumped versions for 17. Dan Abramov, relatively famous developer on the React team, sort of the React guy. And then we get a diff, and this is exactly what happened in that one commit that this tag is referring to, 17.0.0. So that's the basic concept of making an annotated tag, -a. It includes more information. It will prompt you in your text editor for a message, or you can skip that and do -m with the -a, at which point you need to pass in, inside of quotes, a message directly through the command line, and that will be used as your tagging message, just like with git commit. And then we saw that we can use git show to see more information about a particular tag. So far, we've used git tag to generate a tag that refers to the current head commit, but we can also go back and tag earlier commits by using the commit hash. So if I do a git log one line on this React repo, let's take some earlier commit, really any earlier commit. I don't know, there's so many to choose from. Let's take one of them. How about right here, remove JSX plugin. If you're following along, just pick any commit, really. Actually, you know what? I regret this. I think something closer to the top will be easier to see. Okay, how about this one right here? Request to update email. So whatever on your git log, whatever you see, just go back a couple of commits, maybe 5, 10 commits earlier before any tags we've created, and copy one of those hashes. So right now we don't see a tag here, but I can add one if I do git tag and then a tag name and then the commit hash. And this can be lightweight or annotated. I use -a for annotated. To make it simple, I'll use lightweight. So git tag and then tag name. Let's just do something, I don't know, my tag, just to demonstrate. Right? It doesn't have to be a version number. And then I'll put the commit hash. And we don't really see much. If I do git tag, we'll see my tag in there. There it is. But also if I do git log one line or just git log, there it is. We tagged that earlier commit. That's really all I want to show you here. If for some reason we need to move a tag, so we need to have it refer to a different commit, we can use the -f option to force that tag through because, as I'll show you, Git does not like it if we try and reuse a tag. So I've got, let's just take this tag here, 17.0.3. And for whatever reason, it's a bad idea and you should not do this typically, but let's say I wanted to, actually, I made a mistake. I instead want this tag to point to this commit right here. So I can copy that commit hash, and then I want 17.0.3. So I can do git tag, and then v 17.0.3, and then this commit hash. But then Git says, not so fast, fatal, always so dark sounding, that tag already exists. So tag names do need to be unique. I can't reuse that. So that's a problem. But if I want to move that, which is what I'm trying to do, I made a mistake for whatever reason, I want that tag to actually apply. I want it to refer to this commit right here. Instead, I use the -f flag. So just like that, it doesn't have to go at the end, of course, anywhere, but -f, and I force it through. It says, all right, updated that tag. It was referring to this commit. Now it refers to that commit you wanted. And if I do my git log, there it is. It refers to this commit instead of that one. So that's how you can move tags if needed. Not something I do very often at all, but if you need to, use the -f flag. Next up, a very quick one, deleting tags. We just use the -d flag, just like with deleting a branch, and then the tag name that we're referencing. So let's see, which one should we delete? We've got this tag, v17.1.0. Let's do something more obvious. Let's actually add another tag, just where we are right now, git tag delete me. All right, so now if we look at our git log, we have two tags referring to this commit. I want to delete this one. I can do git tag -d for delete, and then delete me. And it deletes that tag for me. And if we look at our log again, we still have that other tag, but our delete me tag is completely gone. So that's all there is to deleting tags. Nice and easy. Now, one last important note about tags has to do with pushing. By default, when you push up changes to a remote repository, tags are not going to be included. So you can push tags actually two different ways. You can push all of your tags that are new using -- tags, or you can go to the Git docs and they talk about how you can push a single particular tag like this, git push and then a remote name and then the tag you want to push up. So I'll demonstrate this, but the problem is right now I just cloned the React repo. I can't push anything, tags or anything at all, because I don't have permission. I'm not a collaborator. So I'm going to make my own repo. I'll just call this one, tags demo. Sure, I'll make it public. It doesn't matter. All I'm going to do is push up all of this here. I'm going to push up React, but I'm going to push it to my repo. So I'm going to add a new remote. So I already have the remote called origin because I cloned. So instead of renaming origin, I'll just go with git remote add, how about Colt? That is the name of my remote now. So I have two. This is Facebook's because I cloned, it just came with that remote. And then this is the one I just added. So now if I try and push up to mine, git push Colt master, it's going to take a while. But eventually, when that finishes, I'll refresh here and it's going to be like a minute or so. I'll edit this out. It's still going. Oh, something new. And that should be it, right? Okay. Whew. I'll refresh on GitHub. Great. I don't see any tags. Hopefully you see that right there, 0 tags. So all the work, everything that I cloned from everything I cloned from React is pushed up, but not tags. So I can push one tag up at a time. If we just pick one, like, my tag, that was one we created. I can do git push origin and then a tag name. Well, I can't push to origin. What a mess. I can push to my remote rather that I created called Colt. And that should be quick. Hopefully we're just pushing up a single tag and there it is, my tag. But if I want to push up all tags, that's where we can use the -- tags flag. So I still need to specify in this case where. So I didn't use the -u option when I pushed, so I haven't set an upstream for this branch, but I'll do git push Colt and then -- tags. So Colt is my remote name, obviously not a very conventional name, but because I didn't fork and then clone this, I had to add a remote. I could have changed the origin remote to point to my repo instead, but anyway, it doesn't matter. If I do -- tags, it now pushes up to my repository, right, that remote, and it's going to push all those tags up. Should be nowhere near as much time though, right? This is maybe 10 seconds or so compared to a minute, which is what we had earlier. And there we go, 141 tags, they're pushed up. So moral of the story, tags are not included by default when you push. You can push them one at a time, or you can push all tags in a repo using -- tags. And that about wraps it up for tags. A pretty simple feature, but also very heavily used, especially in large projects, open source projects, and tightly tied, at least in how they're commonly used, tightly tied to semantic versioning. So that's tags.